Hello and welcome back. Today we'll be doing question 1 from the 2014 Step Paper 3. So let's get started. Question 1. Let A, B and C be real numbers such that A plus B plus C equals 0, and let 1 plus AX, 1 plus BX, 1 plus CX equal 1 plus QX squared plus RX cubed for all real x. Show that Q equals BC plus CA plus AB and R equals ABC. Part 1. Show that the coefficient of x to the n in the series expansion of ln 1 plus qx squared plus rx cubed is negative 1 to the n plus 1 Sn, where Sn is equal to a to the n plus b to the n plus c to the n over n, for n greater than or equal to 1. Part 2. Find, in terms of q and r, the coefficients of x squared, x cubed, and x to the 5 in the series expansion of ln 1 plus qx squared plus rx cubed, and hence show that S2, S3 is equal to S5. Part 3. Show that S2, S5 is equal to S7. Part 4. Give a proof of, or find a counterexample to, the claim that S2, S7 is equal to S9. Pause the video now to have a think, and once you're ready, restart to see if you were correct. Firstly, for this part before part 1, we have to notice that ABC equals R and AB plus BC plus AC is equal to Q follows simply by comparing coefficients after expanding the brackets. Now, we can move on to part 1. Here, we need to remember the Maclaurin series expansion for ln of 1 plus x, which is x minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4, etc. This is equivalent to the sum between n equals 1 and infinity of negative 1 to the n plus 1 multiplied by x to the n over n. Now, we can calculate ln of 1 plus qx squared plus rx cubed. This is equal to ln of 1 plus ax, 1 plus bx, 1 plus cx, which is equal to ln of 1 plus ax plus ln of 1 plus bx plus ln of 1 plus cx. This means that Sn is equal to negative 1 of n plus 1 multiplied by a to the n over n plus negative 1 all to the n plus 1 multiplied by b to the n over n plus negative 1 to the n plus 1 multiplied by c to the n over n. Simplifying this expression gives that Sn is equal to negative 1 all to the n plus 1 multiplied by a to the n plus b to the n plus c to the n all over n, which rearranges to give negative 1 to the n plus 1 of Sn is equal to a to the n plus b to the n plus c to the n all over n. Now let's move on to part 2. Here we'll calculate everything by expanding ln of 1 plus qx squared plus rx cubed directly. This is equal to ln of 1 plus x squared of q plus rx. Expanding this gives x squared q plus rx minus x squared q plus rx all squared over 2, which expands to give q x squared plus rx cubed minus q squared over 2x to the 4 minus qrx to the 5. From this, we can directly see that S2 is equal to negative q, S3 is equal to r, and S5 is equal to negative qr, which proves that S2, S3 is equal to S5. Notice that S2 is equal to negative q because up here we have that S2 is equal to negative 1 to the power of 3 of q. Now let's move on to part 3. Here we'll notice that x squared q plus rx all to the 3 over 3 is the term in the expansion that will give us the x to the 7 term. The x to the 7 term is q squared r x to the 7, and so s7 is equal to q squared r, and s2, s5 is therefore equal to s7. Now let's move on to part 4. Here we'll notice that x squared q plus rx all to the 3 over 3 minus x squared q plus r to the x all to the 4 over 4 will give the x to the 9 term. This is r cubed over 3 minus q cubed r of x to the 9, and so s9 is equal to r cubed over 3 minus q cubed r, meaning that s2, s7 is not equal to s9 if r is not equal to 0. This can be achieved by a number of combinations of a, b, and c. For example, a equals b equals 1 and c equals negative 2, which satisfies a plus b plus c equals 0, and also r equals negative 2, which is not equal to 0. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.